Today we are looking at Chapter 3-4, Linear Functions. So you can turn on a faucet or hose. The rate that the water comes out can be modeled with a linear function. People fill things with liquid every day, like gas tanks, watering cans, and swimming pools. If the liquid enters the container at a constant rate, then there is a linear function that relates time and the amount of liquid in the container. A linear function is a function whose points lie on a straight line when the function is graphed. Let's go ahead and put that down. So a linear function is a function whose points lie on a straight line when the function is graphed. There are many ways to determine if a function is linear. One way is to use a table. If the ratios between the changes in the variables in a table are the same, then the function is linear. So let's take a look at these two tables. So we are going to start with table 1, and it's asking us which function represented by a table is linear. So let's look at this first one. So from 1 to 2, that's going up +1. 2 to 3, that's +1. 3 to 4, that's +1. Down below here, 6 to 8, it's +2. 8 to 10, that's +2. 10 to 14. Ooh, that's +4. So we have 1/2, 1/2, 1/4 are the three ratios. 1/2, 1/2, 1/4. So it said that a linear function has to have the same change between each. The ratios would all be the same. So this one is nonlinear. Let's take a look at the next one. Number 2. So we have 2 to 1. Oops, wrong one. That's going to be subtract 1. 1 to -1. That's subtract 2. 1 to -4, that's subtract 3. Then we look over here. -6 to -3, that's going to be +3. -3 to +3, that's going to be +6. And 3 to 12 is +9. So we have -1/3 as our first one. See, I'm getting it from, why do I keep doing that? Right here. Okay. And then our second one is -2/6, but that could be reduced to -1/3, which is the same as this first one. And the next one is going to be -3 +9. That can be reduced to -1/3, which is the same as the others. So therefore this one is linear. It has the same ratio. Okay. Go ahead and try to figure out the ratio on this one on your own. Okay, so if you got yes, this is linear because the ratios between the change in variables are the same, you are correct. This middle one kind of threw me off, right? So the first one, for sure is 4 over negative 1. The second one was 8 over negative 2, but then I realized you could reduce that to 4 over negative 1. And then the next one was 4 over negative 1. So even though this wasn't a constant change between each of these, because the ratios are the same, it makes it so that it is linear. Okay, let's move on to this next part, discrete data. So discrete data are data that involves a count of items, such as numbers of people or cars. For discrete data, plot the data points and connect them with a dashed line. Okay, so let's go ahead and write the definition for discrete data. Okay, so we should put discrete data is data that involves a count of items such as number of people or cars. And so we connect that with a dotted line. Okay, continuous data is data where numbers between any two data values have meaning. Use a solid line to indicate continuous data. Let's write that definition down. Okay, so once again, continuous data, data where numbers between any two data values have meaning, and this is indicated by a continuous solid line. Oh, not a highlighter. Okay. So I skipped down here because I needed more space. Okay, so now we're going to take a look at this. So graphing discrete data. If a gallon of milk costs $2.59, the total cost of G gallons of milk is a function of the price of 1 gallon. Make a table and graph the function. So we have, first step, determine whether the data are discrete or continuous. You cannot buy part of a gallon of container, so the data are discrete. Okay, so that means that it is going to be a dotted line. Make a table and connect the points with a dashed line. So right here we have the number of gallons, and then we have the total cost. So what we did is a gallon of milk costs $2.59. The total cost of G of milk is a function of the price of 1 gallon. So 1 gallon equals $2.59. 2 gallons, so you're going 2 now times 259 equals $5.18. 3 times $2.59 equals $7.77. 4 times the price of the gallon of milk, $2.59, equals $10.36. So you'll notice on this chart, it doesn't have the exact numbers. So they're just estimating. So 1 is going to be just past 2.5. So that's where you got this dot here. And then 2 is going to be $5.18. So about here. 3, $7.77, real close to the 8. 4, $10.36. Starts at 0, connected with a dotted line, and there you go. So here is one that they want you to try. The function C equals 15T represents the cost in dollars of an adult ticket to a museum. Make a table and graph the function. So go ahead and try that and then come back when you're done. Okay, so you should have gotten a table chart. So T is the number of tickets, P is the price. 1 ticket equals $15, 2 equals 30, 3 equals 45, 4 equals 60. And all I'm doing is multiplying the number that we have on this side times 15, because that's the price of one ticket. So so that's where I got that, is right here. C equals 15 times T. And so T is the one right here. These are all the T's. Okay, so the T's times 15 equals this should have been a C, I'm sorry. I put it as a P, but it's actually a C for cost. And so that's just showing this equals this. Okay, so let's go ahead and try to graph it. So 1 is going to equal 15. 2 is going to equal 30. 3 is going to equal 45. And 4 is going to equal 60. So when we're thinking back to discrete versus continuous, discrete data is data that is equal to, it doesn't matter the numbers between it, right? It's the price of the tickets. So therefore, it only costs $15 and it only costs $30. Like there's nothing between, you can't have a half a person where other numbers between make sense. So because of that, it's going to be a dotted line. Okay, I hope that's what you got. Let's take another look at doing a continuous data graphing. So, Zin lifted weights and burned 100 calories. Then she walked and burned 257 calories per hour. The function C equals 257H plus 100 gives the total calories Zin burned, where C represents the calories and H represents hours walking. Use the equation to make a table and graph the function. Zin can walk for part of an hour, so the data is continuous. Plot the data and connect the data points with a solid line. So we have 0 hours, 100 calories, 1 hour, 357, 2, 614, 3, 871. They are getting these numbers right here by putting these numbers into the equation. Okay, so that's how these numbers are coming to be. Then go ahead and graph. So for this first one, 0 equaled 100, 1 equaled 357, and see, it's not perfect. It's just kind of guessing as where the dot would be. 2 equals 614, 3 equals 871. And then as you see, connected with a solid line, because she could walk for 1 hour and 5 minutes, 1 hour, 10 minutes. So all of these points between here matter. So now what we'd like you to do is try this one. The function A equals 4,000 minus 600m gives the altitude of a plane in feet after m minutes. Make a table and graph the function. Try that one on your own. Come back and see me when you're done. Okay, so this is the chart you should have jotted out. And then I'm going to go through and graph it with you just to show you, right? I'm not being exact in writing all of these numbers. We're just kind of estimating. So 1 is going to be at 34,000. So we're going to call that right about there. 2 is 2800. 3 is, 2200. And 4 is 1600. Okay, so can it go a little bit farther? So it still is moving and changing altitude a little bit after 1 minute, 1 minute and 10 seconds, 1 minute and 20 seconds. So all the times between matter. So therefore it is continuous. So our line is going to need to be solid. Okay. So your homework for this week is going to be page 101, number 5 through 11, odd.